to start again. So Rick was talking about version control, and now Luke Oliff, who is developer advocate at Nexmo, is going to talk about the importance of securing your version control. You probably saw a little photograph of him earlier with his little son, Teddy. So I'll hand you over to Luke.
Thank you for that. Okay, so welcome to my talk on the importance of securing your version control. So I'm going to try and keep everyone in the room, different backgrounds, different levels of expertise. I'm going to try not to lose you all, because I'm going to be talking about some stuff which even I learned over the last couple of years. So whatever your background, expertise, I'm going to try and catch you up quite quickly at the beginning of the talk. Some things I'm going to be talking about is why to version control. I'm going to be talking about Git specifically. I'm going to be showing you a bit of GitHub, because I don't like GitHub. And how Git is already secure and the sort of things that it does to secure your code base already, and then how to make it more secure. So for those of you who don't know me, and as just mentioned, I am a developer advocate at Nexmo. I am obliged to ask how many people have heard of Nexmo? 2. That's pretty good, actually. How many developers do we have? Oh, excellent. That's really good. And how many people version control? Nice. Okay. Okay, so why would we version control? Well, first of all, it gives you a long-term history of all of the code of your project. So you're going to store who's made the changes and why we made them, basically. It's going to allow you to do something like it's going to allow you to do bug tracing if any come up, and you're going to look how that bug was introduced, who introduced it. You're also going to be able to work concurrently with team members on multiple projects simultaneously and work in different streams of work. And it's going to provide you that traceability. So brief intro to Git. Git is actually distributed version control. There's server-client things out there, but Git was specifically built with concurrency in mind. It was originally developed for the Linux project by Linus Torvalds, who also developed Linux, and he developed it because the other solution at the time, they wanted paying, they went proprietary, and everything else that was out there was kind of slow. So, and it was also developed with, sorry, keep up with the clicks. It was also developed with data integrity in mind. So it's going to be doing, it's signing cryptographically your code, the history of your code, so it cannot be tampered with, and it can't be compromised without you actually knowing about it, at least not easily. So how does it do that? I'm going to try not to lose everyone. The information is cryptographically signed with a hashing algorithm called SHA-1, which for the most part is secure, unless you listen to Google or the NSA. So when we commit, we create a hash of a snapshot of the data as it exists, and in that hash as well is what is how it looked before. So what does that mean? Well, this is what a hash looks like. This is me signing culture to digital. So if I was to change a lowercase c to a capital C or get a spelling mistake, that hash is going to change. So you're not going to get 4D, 449, 444, 9E, 7D, blah, 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 blah. So you're not going to get that anymore. The anatomy of how it actually does this is quite interesting. There's lots of these, basically, and they all get smushed down into one, along with the one that preceded it. And that gets added when we commit to a history of these changes. So every time we make a change, that hash has to change. We get alerted to that hash changing, and we get told that this change is ready to be committed. We commit them, it goes in a log. So if every time something changes, we know about it, how is Git not secure? Well, Git is secure. So why are we here, and why are you listening to me talking about it? Well, humans aren't that secure. That's the problem. So let's talk about the human factor. This is Blake. Blake maintains an open source project. Blake also doesn't review stuff properly. Blake silly? Not necessarily. Blake could be pretty stressed. Blake has a large project, of roughly 100,000 downloads a week. Blake also has a full-time job, and his project's nothing to do with his full-time job. Blake has a mortgage, and Blake has kids, and Blake is just human. So when it goes wrong, and some of these examples aren't to do with compromise of projects, but open source projects, they are vulnerable to certain things. So talk about event stream, that was a compromise. The developer, it was getting, I think, 2 million downloads a week. Anyone that knows? 2 million, yeah. And the project owner no longer maintained event stream anymore. He no longer used it. None of the projects he worked on used it. So the first person that came along went, I'll do it. He gave it to them. And the next thing we know, a dependency got added, and that dependency had a vulnerability, and that vulnerability would steal your Bitcoin, which I don't have Bitcoin, but lots of developers who work on these projects do have Bitcoin, and they weren't very happy. Next one is a good one, nothing to do with compromise, but the vulnerability, so to speak, of open source projects. LeftPad was built by a developer who had roughly 200, 250 projects of his own. He had another project called Kik, which had nothing to do with the app called Kik for messaging. However, the app called Kik and the company called Kik, they had a problem with that name, so they wanted it. So they contacted NPM, where they store all this code, and NPM took it away from the developer, so he worked on it quite hard. And you can see what side of the fence I'm on this. So he took all of his packages off the internet, and I think it broke. Is Rick here still?
Yeah.
It broke some of Amazon stuff, right? They've had disappeared. I know Facebook had problems. Google search. It took a lot of the internet basically stopped compiling because this package, this thing wasn't available anymore. And Yummy, which is a great one. So I've spoken before at the meetup about Express and how great it is, but it didn't used to be. At one point, it had a dependency called Yummy. And if you were a developer and you'd logged into Twitter, then as you were installing the dependency of you were installing Express, it would then in turn install Yummy. And Yummy would very kindly go like a tweet for Hot Pockets for whatever reason. There's some bad marketing deal, I don't know. So the integrity and the confidence in some of our products can be difficult to maintain. So we want to do everything we can to maintain that integrity. So one thing, in my opinion, is a project that isn't versioning things, I don't really consider mature. So you should be versioning stuff as a release. So this is how we tag release things in GitHub, in Git, and it's going to basically say, so a version in Git, a state of your code is your hash. Well, we want to say this hash from this point is we're going to release it, so we're going to make that version 1.05, 1.06. Well, that's not necessarily securing anything. It's just adding a little bit of maturity to our project. So how can we secure our Git repository? Well, signing is a big part of that. So I didn't know this until a couple of years ago, but you can actually sign your commits and your tags. So I don't know how many people in the room are aware of signing with private key, public key pairs, but thought you might be. If I get it wrong now, I'm gonna Okay, so effectively asynchronous encryption happens one way and signing happens in the reverse. So in this case, we're going to take our document, which would be our code base at the time we've committed, and we're going to sign it. So we're going to use the private key, which is generated at the same time as the public key, and we're going to create, with that private key and the document, or the code as it exists, a signature. Both those things will get sent to your remote location, GitHub, or any other remote. GitLab supports it as well. And you're going to give them your private key, your public key. Yeah, that's right. In doing so, they can verify using the document and the signature you send them and the public key you've already configured with them. They can verify that nothing has been compromised in the transmission of the data. They can say that it's the same as when you created that signed tag. But what if something was compromised in the commits which came before that tag? And that's where the problem, I think, lies. Before we get onto that, we're going to look at key creation. So once you've installed something called GPG, toolchain, you can then run this command. This will actually generate a key for you. So anyone's actually produced a key locally for SSH access to GitHub or something like that, or other provider, then this is very similar. This produces a key pair specifically for identifying people, I guess. It's a good way to look at it. So it's as simple as this. And then once you've configured Git to know how to use the key that you've produced, then the only thing you need to do after that is -s. Now then that's going to sign your tag. You can even create a password on your key so that when you create your signed tag, you can't create it without your password. So that means even in some crappy spy movie, someone entering your house or your place of work gets on your computer, unless they know your password, they can't pretend to be you at this point. But commits, they are vulnerable still. So someone could spoof a commit just like this, using 3 simple commands. They can change the name and the alias name and the alias email of the committer. And no one verifies this. So in a horror scenario, and there's a great blog post out there called Git Horror Story, if someone could create an account on GitHub or other provider, and they could create the name very similar, 1 character different to your name, and they could branch off a public project, and they're effectively sort of assuming your identity at this point. They can then make some commits to a branch, create a pull request, and if that project owner is like Blake and really stressed, they're probably not going to check that that GitHub account's the same. They're going to see friend has created a pull request and it's actually fixing a problem, and all the commits, they're also in their name. They actually have this person's email address that come from the branch, because you can see all that in the log anyway. So the commits all look exactly the same as they should. And unfortunately, what he's done is he's added some sort of request which sends off personal information to an S3 bucket or something. Right, so commits are still vulnerable. Anyone can make them on your behalf, or anyone can make them on a project, because of Git's distributed idea. The idea of it is a distributed system. So once you're set up and you've told Git how to sign things, you can sign commits. It means when you do a commit, and it's not as bad as it's about to sound, it'll ask you for a password, and it'll verify your identity before it commits to the log. Now, it won't ask you a password every time. If you're like me, I like atomic commits. I commit very often, probably every few lines of code even. It will stop asking me for my password for 5 or 10 minutes, so it doesn't break my process or the speed that I produce things too badly. But I get bored of typing -s, so I do this instead. You can set up a global command, a global config key to say sign every commit. So how do we know this is working? Well, in GitHub, once they've got my public key, you can see that all of my commits are verified. And commits by my colleagues, or my colleagues, other people, they may not be verified. These other commits, they may even be by me, but I can guarantee, because they're not verified, actually wasn't me. How do we automate the process of verifying commits? Well, at the local level, we are verifying my identity, because everything's signed, everything requires my password to be able to create a commit, but GitHub won't do anything with that. I don't know if other providers like GitLab do automatically, do they? So you can reject. Yeah, that's amazing.
You have to enable it. Oh, yeah.
I'm going to have to look. Don't maybe change. Right. So John Agan, he produced this. It isn't a working code or application or package. but there's some really good examples here of code that you can use to build a small webhook server to verify commits. So you own the server, so no one can abuse that or compromise that, and how you then verify commits are done by you. But it will effectively check the committer's alias email address for every commit that they're adding against the person pushing the code off to the remote. So then all of a sudden you're tying up all the human vulnerabilities of your project. You're verifying the person sending the code to the remote is who they are, who they say they are, and at a local level, you're verifying that you are definitely the only person making that commit. So, there are other things that we can do, and I'm not going to go too long. I had a list of 10, and my colleagues who are much more experienced at getting up on stage said, do not say 10 best practices. The audience will only remember 2, pick the 2 for them. So I've done that. So, enforce signing for all committers. It's got to be, because until you do this, you're only protecting the integrity of the committer that is signed. Every other person who's not signed, well, they could be spoofed, and that's vulnerable for their personal brand, should we say, and also your project. So if every person is verified, then the only person doing naughty stuff you know is one of your contributors. And review access rights to your system. This pretty much goes without saying on every system you've got as a company. Review access rights regularly, and don't give access to things you shouldn't have. Now, the speaking gods have shortened my talk by 5 minutes, which is frustrating. So I have come to the end of my talk early. Especially devs, take note. You should be verifying your commits, I think, because if you're not, then there is a vulnerability there for your commits to be spoofed. And a secure web is good for everyone. Everyone should be HTTPS by now, without fail. As I've been talking, hopefully if it's worked, I have been tweeting resources to things I've spoken about. So you should be seeing tweets about links to how to set up these GPGs like granularly, step by step, how to add them to GitHub. And that's it. Thank you very much for listening. We've got some time for questions.